Right, so we'll continue looking at law of sines. So it's still section 4.2. Just a reminder of what the law of sines formula is. So it's sine of alpha over A equals sine beta over B, which equals sine gamma over C. Remember, you never use all three parts at the same time. You only use two parts at a time, which sets up a proportion. And then to solve a proportion, we cross multiply. So as far as explanation, there is nothing I need to really explain today, other than just starting examples. Okay. For those that weren't here, you can look at day one of the video, and it'll show you where the formula, like where it comes from, and how we use it.
Wait, so the only difference is you added?
What's that?
Wait, what did you say the only difference was? I was just writing it down. I didn't hear you. But,
well, the difference today, we're going to look at problems that have the to solution and the no solution.
okay.
So we didn't do that yesterday. So everything is going to be...
I thought we looked at the ones with the two solutions yesterday.
No, the second solution never worked. It always came out too big.
We did the problems where it could have, though, right?
Yeah. We did one where it could have, but it didn't. Yeah. Now we're going to look at ones where it can and it will. So today it will work. And we'll do one where it won't work. We'll do both. All right, so remember the three types of problems you can use law of sines for. Angle, angle, side, angle, and those two are fine. You don't have to worry about the two solutions. This one, we do. Okay, let's make a sketch. If you didn't know from the table, like I can tell looking at the table, we have a completely empty row. I can't find anything in it at all, and I have a completely full row. That's how I know looking at the table that it's the two solution, one solution, no solution case. But if you didn't know from the table, let's draw our sketch. It's not going to be to scale. A is 6. Alpha is 35. B I can put over here is 8. Beta, I don't know. C, gamma, don't know. So if we wanted to describe that triangle using the three letters, what kind of triangle is it? Corey?
Just side weighted, angle side.
Side.
Angle side.
For it to be side, angle, side, I would have to know gamma. Because side, angle, side means the angle is sandwiched between the two S's. In this case, the angle is not sandwiched between them. Joe?
Side, angle.
Yeah. You have a side, and an angle. That's the only case that we studied yesterday. It's the only case we're going to study all week where you get a check for the second answer. All right. So what do I have to find first? I'm kind of trapped, and I got to find beta. So that's going to be the first. That's going to be the second. And C will be the third. All right. So let's set up law of sines to find beta. How about Eric? Can you tell me how I would tell me what row I would have to use to find beta?
Alpha.
Yeah, you're pretty much stuck with that row. It's the only row that has everything in it. And then, of course, we're going to use the row that has what we want to find. So could you set that up for me, Eric? To find beta?
I'm not really sure.
All right. Do you remember what goes in the top?
A?
Nope. Sides go in the bottom.
Oh.
So anyone help him out? What's going to go in the top, Chris?
Would it be the sine 35 over 6?
Yep. So it's going to be sine 35 over 6. So sine of an angle, divide by what's across from it. Sine of another angle, divide by what's across from it. So what's my other angle that I'm going to use?
Sine beta.
Sine beta over
A.
B. Yep. So
Wait,
sine.
do it here,
No, you're right. You're right.
No. Yeah. I thought you were putting that to me. I'm saying that.
Yep. So sine beta over B, which we know is 8. Okay. Now what do I do with that?
Cross multiply.
Yep. Cross multiply. Good. So I'm going to cross multiply. I get 8 sine 35 equals 6 sine beta. Now there's two things I have to get rid of on the right to get beta by itself. How about, Derek, what's one thing I gotta get rid of?
6.
6, yep, and how am I gonna get rid of that?
You divide by 6.
Okay, I'm gonna divide by 6. And then there's one other thing I have to get rid of.
Sign.
Sign, and how am I gonna get rid of that?
Inverse sign.
Inverse sign. So I'm gonna do both at the same time. So I'm gonna take what's on the left, I'm gonna divide it by 6, and I'm gonna take the inverse sign. Okay, and now beta is by itself. So one of two things is gonna happen when I type that in. I'm either gonna get a number, or I'm gonna get an error. Okay. So let's see what happens. So inverse sign, my calculator's still in degrees, it'll stay in degrees now until I shut it down, shut the program down and start it back up. So I should be good with that. 8 sine 35 over 6. 8 sine 35, make sure you close the parenthesis, and over 6. Okay, so I get 49.886. So this is not a no solution. There is a solution, and it's right there. Okay, while I'm typing these in, does anybody want to practice it on one of my calculators? Just to try it? Yeah, let me get those. All right, so we've got one answer, 49.886. This is the case where I got to check for the second. So what do I do with 49.886?
On the rate.
Remember, what do we do to get the second answer? Yep. Subtract it from 180. So 180 minus 49.886. So if there's a second answer, it's 130.114. I said if because now we got to figure out, does it fit? Okay. When I say does it fit, what do I mean? What am I trying to check for? Christian?
If all the angles add up to 180.
When you say all the angles, which angles do you mean?
I mean beta, gamma, and alpha.
Not quite. Joe?
Wouldn't you just add up alpha and beta because that's the only ones you have up to 180?
No, you wouldn't add alpha and beta. If there's a second answer, this answer is a completely separate answer for beta that has nothing to do with 49.886. It's actually, if I was going to draw it.
I meant like you would add up beta 2. I didn't meant that beta.
Oh, beta 2, I gotcha, yeah. Add that to,
You just add that to alpha.
yes.
That's when you would.
Take that new answer for beta, which we're going to call beta 2 if it works. Add it to what was given and see if they fit. Okay. Can you fit a 130 degree angle and a 35 degree angle in the same triangle? Yeah, that only adds up to 165, so the second answer does work. So I'm going to call that beta 1, and I'm going to call this one beta 2. Yeah.
Well, wouldn't that not be like in. Isn't gamma always have to be bigger than beta though?
No.
But the angles.
No, the angles can be, remember, we don't have a hypotenuse anymore, so C can be the biggest side, C can be the smallest side, A could be the biggest or smallest. Any side can be the biggest or smallest, any angle can be the biggest or smallest. So now that beta has two answers, what else does that mean? Gamma has two answers. And C has two answers. So what I'm going to do is I'm going to just kind of circle things in color and show you the two problems we're solving at the same time. I'm going to call them the red and the green triangle. Yeah?
Why don't they all have two answers?
It's an all or nothing. They either all have two answers, the ones you have to find.
The alpha, A, and B.
Oh, the ones that were given? Because those were given. Whatever's given, that's the way it is. You don't have to worry about that having two answers. All right, because these triangles that have two answers, they share these two sides and they share that angle. Those A and B are going to be in both, and alpha will be in both. Those are the only three things that they're going to have in common. The other three things are all going to be different. So alpha is going to be in the red triangle, beta 1 is in the red triangle, and gamma 1. Those three things that I just put in red all have to add up to 180. That's one triangle we're going to solve. The other triangle we're going to solve has alpha in it, beta 2, and gamma 2. So the three green boxes also have to add up to 180. That's a different triangle. Right. If you want to look at the sides, A is in the red triangle, B is in the red triangle, C1 is in the red triangle. Those are the three sides in the red triangle. And then A is in the green, B is in the green, C2 is in the green. So you can see A, B, and alpha are in both. Beta 1, gamma 1, and C1 are the red. Beta 2, gamma 2, C2 are the green. So it's like we're solving two totally separate problems. So let's get gamma 1 first. What are the other two angles that are with gamma 1? Christian?
Beta 1 and alpha.
Beta 1 and alpha. Yep. So I'm going to add those up. So 35 plus 49.886. And I'm going to subtract that number from 180. So I get 95.114. Now at this point, I do have enough information. I could finish off the red triangle and get C1, but I'm just going to get gamma 2. Okay, while I'm getting the gammas, and then I'll come back and do C1 and C2 later. Okay. What are the two angles that I'm going to add up for gamma 2? Court?
Alpha and beta 2.
Alpha plus beta 2. So 35 plus 130.114. I get 165.114. And then add that to 180, or subtract it from 180. And I get 14.886. Okay. Now I've got the angle I need to find C2. Right. So we have to find C1 and C2. So let's start with C1. That's the red triangle. I see two rows in red that are complete. Okay, I have a choice of B and beta 1. That's a red row that's complete. Or A and alpha. That's another red row that's complete. Which row should I use?
A and alpha.
Yeah, we'll stick with A and alpha because it was given and there's no decimals. So to find C1, I'm actually going to start by doing that. All right, so let's, you know what, let's put it over here so I can. So to find C1, we're going to do sine 35 over 6 equals, and what angle am I going to use to get C1? Joe?
Gamma 1.
Gamma 1. Yep. Sine 95.114 over C1. Okay, so when we cross multiply, we're going to have 6 times the sine of 95.114 equals C1 times sine 35. But then we would have to divide by sine 35 to get C1 alone. Okay, so there's our answer for C1. Okay, now quickly, if I just look at the red triangles, the red angles, gamma 1 is the biggest. So that means C1 is going to be the biggest. So it's got to be bigger than 8. But it also has to be smaller than what?
14.
It's got to be smaller than 14 because these two added together have to be bigger. So I'm looking for an answer between 8 and 14. All right, so let's see what we get. So 6 sine 95.114 divided by sine 35. Okay, so I get an answer between 8 and 14. So it seems reasonable. 10.419. Okay. So now let's, you know what? I got a little room up here. Let's do C2 up here. So now I'm focusing on the green triangle. So again, I see two rows that are complete. A and alpha, B and beta 2. I'm going to stick with A and alpha because those are my givens. So sine 35 over 6. And what's going to go on the other side this time? It's got to be.
Sine of 14.386 over C2.
Yep, 14.886 over C2. Okay. And now, just going to block this one off. So now I'm going to cross multiply, and I get 6 sine 14.886. Divided by sine 35. And we're just doing the cross multiplying, but we're just not showing out the cross multiply step. So when I type this in, the easiest way for me to do it, I can just bring up the last thing I typed in, and I only have to change one number, 14.886. 86. Okay. And let's just kind of predict what our answer should be between. Let's see. Gamma 2, if you compare it to the other green angles, how does it compare? It's the smallest. So look at the green sides. I know C2 is going to be smaller than
6.
It's going to be smaller than 6. Okay. So let's just see what we get. I get 2.687. Alright, so now I just kind of check it quick. I look at the green. I say, alright, for the green, beta 2 is the biggest. Beta is definitely the biggest side out of 2.6, 8, and 6, so that looks good. Smallest angle is with the smallest side. We already checked that. So it looks good. Okay, so again, this kind of problem, it's not really harder. It doesn't require any additional skill from what you've already done. It just requires doing the same thing twice. Yeah.
Why is there 2 betas and 2 gammas?
All right, I'm going to show you visually right now. I'm going to draw a picture. Yeah. That's my next step. So, whenever you have a 2-solution case, they always have 3 things in common. A side, and an angle. Okay. Those 3 things have to stay the same in each triangle. So I'm going to draw 2 triangles right now that have a side, and an angle in common, but they're 2 different triangles. Right? So I'm going to start with this one. Okay, so I've got a triangle. And now I'm going to make a second one. So the first thing I'm going to do is I'm going to take this side and I'm just going to make a copy of it. Does everyone agree that that side is the same as that side? Okay. So I have got my side. So 2 sides are the same. Or 1 side is the same. Okay, second side. I'm going to take this. I'm going to make a copy of it. This time, I'm going to flip it. So I kind of made a mirror image of it. Now, is it still the same length as the above side?
Yes.
Yeah, if I measured it, it's just a mirror image, but it's still the same. All right, so now that side is the same as that side. So there's two triangles. Well, it's not a triangle yet, but I've got two sides the same. Now the third thing I'm going to do is I'm just going to connect the bottom. And if you're looking, you're like, well, wait, where's the angle that's the same in both? Let me group it all together. Right there. So that angle in the lower left is exactly the same size in both. So what I did is I just created two triangles. They have two sides, exactly the same length, and one angle, exactly the same measure, but everything else about them is different. That's how you can get two answers. Does that make sense? I can't do that with any other type of triangle. Like, so if I gave people like sticks to build stuff, and I said, all right, here's two sticks, and I want the angle over here to be a certain amount of degrees. Some people might build the top triangle, some people might build the bottom. But if I gave you like 3 sticks and they were all the same size, right? I gave everyone sticks that were like 5, 6, and 7 inches. Everyone's triangle would look exactly the same. There's no way if I gave everybody sticks 5, 6, and 7 inches that people could make different triangles. It's impossible. It can only happen in this case.
Isn't the reason why is because there's no like two fixed angles? Because then the third one always has to be the exact same one.
Yeah, well, that's part of it. The only thing you got to be careful when you talk about angles is if I said, all right, I want everyone to draw a triangle, and I want all the angles to be 60, 60, 60, 60. Would everyone's triangle look the same?
No.
What's that? Could have different side lengths, right? So if I said, all right, everyone make an equilateral triangle. Some people, I don't think I have an equilateral triangle. Maybe I do here. Yes, I do. Okay. Some people's equilateral triangle might look like that. Some might look like that. But all the angles are exactly the same. 60, 60, 60. So we just have to be careful if all you talk about is angles, you have no scale. So whenever you have angles, you've got to mention at least one side in there too. But yeah, so if you've got 2 angles you know are the same, and a side that you know is the same, then you're good. Everyone's triangle would look the same. Any other questions on that? Okay, so that's why when we solve problems, I'll never give you angle, angle, angle. It's impossible. Every single problem we do for this week has to have at least one side. So we did that yesterday. We did that yesterday. We just did this one. And then tomorrow we're going to look at this one. I won't check it off because we haven't done it. And side, side, side. All right, so if you look there, every single case we do all week has at least one side in it all the time. The 3 on the left are what you use law of sines for. The 3 on the right, or the 2 on the right, are law of cosines. So we'll look at those tomorrow. Okay, so that's the worst case you can have because you got to do everything twice. Let's take a look at this one. Without even making a diagram, how do I know that this problem is law of sines?
Is it open row?
Joe?
Is it a completely empty row or is it a completely full row?
Okay, well the fact that I have a full row, that's enough to tell me that it's law of sines. Now the fact that I have an empty row, and you have no way of finding anything in that row, what else does that tell you? Not only is it law of sines from the full row, but what does having the empty row tell me? Yep?
You could have more than one answer or no answers.
Yes. Whenever you have the totally empty row, that's where you could get the more than one answer, no answer, or maybe it works out like the one in homework, just one single answer. All right, So because of that, what do I have to find first? I have no options. I have to do this first.
Let's find beta.
Which one?
I mean, like find alpha.
Alpha, yep. So let's set it up and let's see what happens. So I'm going to use the two rows where my arrows are pointing. And what would be, Oscar, what would be my proportion that I would set up here?
And do sine 50
Yep,
over 1
over 1, okay.
and sine A.
A is going to go in the bottom.
Oh, yeah, sine of alpha.
Yep, sine of alpha over A. So sine 50 over 1 equals sine alpha over 2. Now it's just sine 50 over 1, so you don't even really need to put it over 1 because when you divide by 1 it doesn't change it. But let's see what happens. So we get 2 sine 50 equals 1 sine alpha. You could just write sine alpha. And now we want to get alpha alone, so what am I going to do to each side? Yep.
The inverse sine.
Yep, I'm going to take the inverse sine. And take the inverse sine. Inverse sine, regular sine cancels. And now we type that in. So it's inverse sine of 2 sine 50. Second, inverse sine, 2 sine 50. Okay, someone that has a calculator, when you try typing that in, what do you get?
Domain error.
Domain. Did you type it in right?
Domain error.
You did too?
Yeah, I typed it in exactly.
Maybe you copied how Christian typed it in. Maybe not.
No, it's exactly the same.
Yeah, it's probably exactly the same. I think you both probably typed it in right. So let me hit enter. And mine says domain error. Okay, we have a problem here. Let's look at just this part. 2 sine 50. I get 1.53. Okay. Think of the graph of sine. When we studied that graph last week, what was the highest and the lowest that it went? It only went up to 1. Well, 2 sine 50 is 1.53. But the graph only goes up to 1. So when you try to do inverse sine of 2 sine 50, you're basically asking the question, where did the red line and the blue wave cross? No, they don't. This value is too high to take the inverse sine of. It has to be between -1 and 1, and it's not. So that means that there is no solution for alpha, which means I don't have an angle I can add to 50 to get beta. So what does that now mean about beta? There's no solution for beta either. Which means if I can't find the angle, I can't find the side across from it. So this triangle is impossible to sketch. So if I gave people like sticks that were lengths 2 inch, 1 inch, and I said I want you to make sure you make gamma 50, you wouldn't be able to draw a triangle. Okay? And I'll try to draw it and show you what happens. All right, so let's take a look at it. So the first thing I need is something that's length 1 and then something that's double that, length 2. Doesn't matter if it's 1 inch, 1 foot. Let's just call that 1. So that's length 1. This is going to be length 2. Just put 2 of the single units together. Try to line them up best I can. Okay, and I'm going to just group them. Okay. Any question on that? I have length 1, length 2. Now, A is the one that's length 2. C is the one that's length 1. All right. So A has to be length 2. What I'm going to do is I'm going to set A, which is the longer one, at a 50-degree angle. That's exactly 50. Okay, I measured it out. There's a protractor on here, so I could actually use a protractor and draw it out, and it works. It works fine. So that's 50 degrees. So I got to make sure I set that as close as I can to 50. All right, so let's see if I can. Oh, there we go. All right, so that's it's kind of it's not really super sensitive, so it doesn't. Yeah, that's close enough. It's pretty close to 50. Now I can't turn that. I have to keep that set at exactly a 50. Now C, let's move that over. C is the 1 unit. Okay. Side C is over here. So that comes off the end of A. Now, to put it over there, this is just kind of weird on the smartboard. See how it doesn't have a little green handle on it? So I can't turn it. But if I go like this, if I group it with something, and then I erase the little dot, now I have the green handle on it. So, I don't know, just something I figured out one day. So C, you can turn however you want. They didn't tell me what the angle up here had to be. I just have to put C on the end. Now, side B, that was blank. They didn't tell me how long side B has to be. So you can make B as long or as short as you want. But you can't change it for being horizontal because then you'd mess up the 50. Right? It's got to stay horizontal, and that's got to stay like that. Is that third side ever going to meet?
No.
No. I mean, I can try. I can turn it more like that. Now it looks closer, and I can try to shorten this up. But it's never going to meet it. All right? So no matter what you try to do, you're always going to have a gap there, which means it's no solution. So visually, that's why there's no solution. Okay. Any questions on that? Okay, so let's take a look. Those are the two that we're going to look at that aren't word problems. Let's look at one that is. All right, so what we're going to do here is we're going to measure the height of a mountain. And the way we're going to do it, we're not going to know how far away we are from the mountain. If you knew that, then you could do right triangle trig. But we don't know how far away we are. We're just going to measure 2 sightings of the peak. So what we're going to do is we're going to stand in one spot, set up a tripod, aim some kind of scope at the peak of the mountain, probably on like a transit, and that's going to tell us the angle that we had to point it at to be exactly at the peak. And then we're going to do the same thing. We're going to back up 900 meters, set the tripod up again, and then measure the angle to the peak from that spot. So we're going to get 2 different angles, because think about, if you're looking at something and you're very close to it, you might have to look up pretty steep. As you start to move away from it, you don't have to look up as steep. This is like a movie screen. Right? You look close, you look up steep. Further away, you don't have to look up as steep. So when we're closer, we get an angle of 47 degrees to the peak. And when we're further away, we get an angle of 35 degrees. So you can kind of shorten that. If you just want to say like angle 1 equals 47, you don't have to write the second observation results in. Like you could just say angle 2 equals 35. So you can shorten that up a lot. It's up to you. Yeah.
Is it angle either side?
The type of triangle we're going to draw, you'll see in a second. I actually don't remember off the top of my head. Now, angle of elevation, that's the angle that something makes with the ground. So like if the table was our surface, and I take something from the table and then rotate it up, the angle between you know, what I had here and here, that's called the angle of elevation. Just what you're pointing, how much it's pointing up. Right, for our purpose, we're just going to assume the transit is level with the ground, which probably isn't true. Most transits, you set them up on a tripod, they might be like 4 or 5 feet high. And I actually had a picture I wanted to bring in, but I forgot. It's actually a picture when I was on vacation this summer. I was in, could have been Michigan or Illinois. I don't remember what state it was in, but it was around there because I went to a few different states. And there was a park in one of those states. And there was actually two, I think they were like National Park Service employees, and they had transit set up, and they were measuring something to figure out if they could put in like a ramp, because it was like a dune, and it was very steep, and they wanted to see if they could put in like a wheelchair ramp to get down. It was like a 30-foot drop, and they were trying to see how long the ramp would have to be, which would have to be pretty long because you can't have wheelchair ramps steep. So they were measuring it, and I took a picture, and I was like, I'm going to use this. And I totally forgot it. So maybe I'll bring it in tomorrow. We'll see if I remember. All right, but for now, we'll just stick with this problem. All right, so assume the transit is level with the ground. All right, so we get a lot of information there. It would be helpful if we did what with all that information? Yeah? What's that?
Put it in that table.
Okay, we could make a table. What else could we do? What do we do in a lot of our problems besides a table? Yeah, we should make a picture because this is very confusing without a picture. So, first thing we need in the picture is the ground. So there's our ground. That'd be nice if we made the ground straight. That's always helpful. Alright, so there's the ground. And we have a mountain somewhere over here. There's our mountain. Pretty steep, so be careful if you climb it. So we're going to measure the mountain from 2 different spots. Here and here. I don't know how far away I am from the mountain, but I know the distance between the 2 spots is how much? 900. So 900 meters from here to here. Now, when I measure to the peak, you kind of pretend like there's a laser on that scope and you're shooting it right to the peak. I'll put it as a dotted line so we can kind of remember that's our laser, that's our sighting to the peak. And then we back up 900 meters and we do another sighting to the same peak. All right. Now, when I do the first sighting, what was my angle of elevation? 47. And then when I did the second sighting, what was my angle of elevation there? 35. Okay, so my goal is to find this line that I'm drawing. That's the height of the mountain. So I'll put that in a different color, and that's what I want to find. And the height is perpendicular. Height is always measured straight down. All right, well, if you start looking at this triangle right here, and then I'll just slide it down. That's 47. That's that. And that's the height. All I want to do is solve for h. What kind of triangle is that? It's a right triangle. So that should be easy to solve, but why can't I solve for h in that picture?
We don't have 2 variables.
Hey. So I've got, can you say that again, Joe?
You don't have 3 variables included in the degrees.
Don't have.
So like, you need 3 variables to figure out a triangle, and you only have 2.
You mean 3 pieces of information? Yeah, so we need 3 numbers. So we have too many variables. We don't know any of the sides. So for now, even though I would love to work with that triangle, I can't. I'll have to come back to it when I know something else. But there's another triangle here that I can work with. Does anyone see the other triangle in the picture? It's not a right triangle, but yeah.
The one on the left.
The one on the left with the dotted lines. This one right here. Now, conveniently, that triangle shares a side with the triangle that I would rather work with. They share that side right there. So all I have to do is figure out that side, that's x, and then I'll know the hypotenuse in that triangle, and then I can find the height very easy. Okay, so let's label what we know in this other triangle. We know this side is 900. We know this angle is 35. Now, the angle outside is 47. That's not really helpful in this triangle. How can I get the angle inside? Yeah.
Take 180 and just subtract 47.
Yeah, take 180 minus 47. And now I have this angle. And now that I have two of the angles, if I want to use the law of sines, I need an angle and the side that's across from it. I don't have that yet. But what could I do to get the angle that's across from 900? Yeah.
180 minus 133, 35.
Yeah, just take 133, 35, add them up, subtract out from 180, and you'll get 12. So this angle up here is 12. Now I'm ready to use the law of sines. I finally have an angle and the side across from it. So let's set up our law of sines. Okay, remember, sine of an angle, divided by what's across from it. Sine of an angle, divided by what's across from it. Look at your picture. Sine of 12, and what's across from 12? 900. Sine of an angle, divided by what's across from it, equals sine of an angle, divided by what's across from it. My goal is to get x, and then I can find the height. What angle is across from x? 35. Okay. So now solve for x. 900 sine 35 over sine 12. Okay, so we get 900 sine 35, close parenthesis, divided by sine 12. So I get 2,482.8. Is that the height of the mountain? No. What is that? In our problem, we called it what? Just x. 2482.88. So x is 2482.88. Now I'm good to find the height. Okay, you could use what we learned this week, but I would just go back to what we learned last week. From the perspective of the 47, figure out the names of those two sides. So h is farthest away, so it would be opposite. And what about 2482.88? That's your hypotenuse. Which trig function has opposite and hypotenuse in it? Sine. So the sine of 47 equals opposite over hypotenuse. And what would be my last step? To get h by itself and get the 2,482.88 on the left side. Yeah.
Multiply that whole side.
Yep. So the height of the mountain is 2,482.88 times sine of 47. So it's about 1,815.86 meters. Yeah, Joe?
Could you just have put your answer for the last one, and then put sine times the sine of 47?
Yeah, that's what we pretty much ended up doing. The answer for the last one times the sine of
I was
47.
wondering if you would say it's okay.
Yeah, yep, that's fine. Yep. So in terms of mountains, that's, I mean, around here, that's pretty tall. Mount Washington is, I know it's 6,288 feet. I think that's over 2,000 meters. But that's the highest mountain in this area in the Northeast. In terms of mountains like out west, Colorado, or mountains in Alaska or something, that's like a baby mountain. Mountains go much, much higher. And then if you compare it to like Mount Everest, that's well over 6,000-7,000 meters. It's pretty high because that's over 20,000 feet. So much, much higher. Okay, but for this area, that'd be a decent sized mountain. Any questions on that? Okay, so that one was our hardest word problem because it was really 2 steps. You couldn't find what you wanted right away. You had to get something else first to then get what you wanted. All right, so the last one we're going to look at is about 2 Coast Guard stations. So the idea is we've got 2 Coast Guard stations, and they call them Zulu and X-Ray. All we know about the stations is they're right along the coast, and they're 120 miles apart. So already, what do you think we're going to do in this problem with the information we're being given? To make it easier to solve. Because they're going to give us all kinds of information.
Simplify it.
And how are we going to make it simpler to understand for someone? Sketch it. Yeah, you're going to sketch it out. So you got 2 Coast Guard stations, and a ship sends out a SOS. Let's say that they send out the SOS using a light on their ship. All right, so they don't have a radio. Doesn't work, it broke. Someone dropped it. Their GPS doesn't work. They threw it overboard for some reason. It's nighttime, so they can't see any landmarks. It's cloudy, so they can't see any stars. They pretty much have no clue where they are. And they have no way of reaching anybody except using a light on the top of their boat. That's all they have. Big, very powerful light. So that's how they're going to send out an SOS. So, Station Zulu sees the light, and all they can say from their spot is the light is that way. They don't know how far that way, but they see it, right? It might be 20 miles, it might be 30 miles, it might be 50 miles. Maybe depending on visibility, they could figure out, well, visibility is 100 miles, so we know we can't see farther than that. So it's less than 100 miles. But they don't know exactly how far away it is, okay? But they see it. And they see it, and they mark the direction they see it at. And just take a compass, and okay, it's that way. So they see it at a heading, or a bearing, 40 degrees east of north. So if you were facing north, and then you go 40 degrees east, it's like going to the right of north a little bit. Almost halfway between north and east. 45 degrees would be halfway between north and east. So this is 40.
40 east of north?
Yep. And now the other station does the same thing. So there's another station 120 miles over, and they say, oh, you know what? We can see the light too. So what do you think is happening here? 2 stations can see the same thing. We can basically figure out exactly where that light is, as long as we can see it from 2 different perspectives. So this station, the call to station X-ray, they look at their compass, and from their perspective, they see the light at a bearing 30 degrees west of north, because they're 120 miles in a different direction. So the question is, how far is the ship from each station?
Don't you get like 4 variables there?
No,
never mind.
No, you'll see when we sketch it out, we're going to end up with a single triangle. And the sketch is the hardest part. Once we get the triangle, we just use law of sines and solve it. We just have to draw it out. And they actually do this kind of thing. I know they do it with like a forest fires. If you ever been up in like one of the ranger stations, they have a disc up there and they can spin it and it has a sight on it. So if they see a fire, all of its glass windows all the way around, they just spin this big disc. They line it up, the sights with the fire, and then they can look down at their map and say, oh, there's a fire and it's at 20 degrees or a heading of 20 degrees. And then if another ranger station can see the same fire somewhere else, they just tell the other, they say, oh, well, I can see it from this direction. And then as long as like an airplane knows both directions, they can triangulate exactly where the fire is and get to it. It's really hard if one person can see the fire, because if they just see smoke and they don't know if it's 10 miles or 20 miles or 50 miles or 200 miles away, they can't really pinpoint where it is. You've got to see it from two perspectives. If you can get a third perspective, that's even better. But two is enough. Okay, so let's draw it out. So first thing we've got is the coast. On this side will be land. This side will be water. We've got two Coast Guard stations along the coast. I want to make sure I label them correctly. Zulu is to the west, so that means it's left. So Zulu is west of X-ray. And what else do I know about the Coast Guard stations?
120 miles apart.
120 miles apart. Okay, and there's a boat out here, and they shine a light. Each station sees the light. So I'm going to draw in kind of like a beam that represents each station seeing that light. All right, so we'll just make that dotted so we remember that's a beam of light, and that's dotted as well. Now, each station tells you a bearing from their perspective. So it says, Zulu says that the bearing is 40 degrees east of north. All right, so what I'm going to do is I'm going to put in a line like this. It'd be nice if it was straight. And that line is going to represent north. Right there. North. And what does it say? The bearing is 40 degrees east of north. Well, if this is north, this line is to the right by 40 degrees. It's 40 degrees east of north. Any question on that? Okay, now the other station does the same thing. They measure another bearing. So I'm going to put north right here. I'm kind of simplifying it a little bit, but it works okay for this problem. So there's north. And what's the bearing that this station sees the light at? 30 degrees west. West is to the left. So 30 degrees west of north. Okay. So now our goal is to figure out the distance from each ship. Each Coast Guard station to the ship. Okay. Let's take that triangle, move it down here, so we can kind of abstract it out from the problem. And let's see what we know. That's 120. Now, I have the angle outside. I really want the one inside. What's the angle where the question mark is? Yep. 50. We've got a 90 right there. So this is 50. And how about the other question mark? 60. But now to use the law of sines, I need an angle and the side across from it. I don't have that yet in that picture. But what else could I find there?
third angle.
I can get the third angle, and then I'll have an angle and the side across from it, and then I'm good. What would the third angle be? 70. Okay, so let's call this A and B, or you can call it X and Y. You've been using A and B, so it's probably more familiar. Okay, so let's find A. Start with the row that's complete, if you were to write that as a table. Sine of what?
Cody.
70, yep. Over 120. In fact, when we find B, we're going to start with that same thing. Sine 70 over 120. All right. Now to find A, what's going to go on the right side?
60 over
Sine 60 over A. We'll come back to that. How about to find B? Sine 50 over B. Right, so when I get A by itself, I'm going to get 120 sine 60 divided by sine 70. We type that in, and that's the distance between, what was it? Zulu and the ship. And now to get B, basically it's just one number that changes. 120 sine 50. That should cross multiply and then divide by sine 70. That's the distance between X-ray and the ship. Okay, does anyone have an answer for what the first one comes out to? 110.59. Thank you. So that's about 110.59. And then how about the other one? I don't have an answer for that one. $97.824. So I'll just go 97.82. So now how might they use that information? Well, they might say, well, Coast Guard Station X-ray is closer. So if we're going to send out a rescue, maybe we should send it from there. But maybe X-ray only has like a ship, and Zulu has a helicopter. So either they have the helicopter, so they might be able to get there quicker. But that might also depend on, if it's windy, maybe it's too windy to fly the helicopter, so we got to go with the ship. Also, they might have to take into account the current. If it's going to take them 6 hours, maybe it's awful conditions, right? Maybe it's going to take them like 4 or 5 hours to get there. Well, in 4 or 5 hours, that boat's probably not going to be there anymore. So they kind of have to look at the current and figure out which way, maybe if their engines don't work because they're stuck or whatever, which way is the current moving the boat? So they got to make a prediction of where that boat is going to be in 4 or 5 hours, and that's where they have to head towards. So they can see the light, but they might not want to head towards that. They might want to head where the current is going to push the boat. So that may change which station sends out a rescue too.
When you always want to go towards the light. The light of the boat is.
Yeah, you'd always want to go towards the light. I guess maybe if the light burnt out,
Oh yeah.
then all of a sudden you have to say, uh-oh, we're going to go where we think it's going to be. But yeah, if the light could stay on, that would make it easier. Yeah. Well, let's say the light burnt, maybe the battery is burnt out or something, the light burnt out. Now they got to make a prediction of where they think the boat would be. All right? Okay, so the homework tonight, it's on the same page as last night, 29 to 35 odd. And then 39 and 43. Okay, so we should be on track to finish everything up tomorrow for the week. We'll do law of cosines. And then Thursday will be review day.